Hello grade 12s and welcome to another exam practice video on electric circuits. This question says 3 resistors, a light bulb and a cell with an internal resistance of 1 ohm are connected as shown in the circuit diagram below. The resistance of the 3 resistors are R, 2R and 6R respectively, and the resistance of the light bulb is 80 ohms. When switch S is closed, the voltmeter and ammeter have readings as shown in the diagram below. So we're going to close the switch and we therefore have on the ammeter a reading of 0.1 amperes and on voltmeter V2 we have a reading of 3 volts. Now before we go ahead and answer any of the questions, let's try to understand what is happening in the circuit as far as current is concerned. Firstly, we know that conventional current, is going to flow out of the positive terminal of the battery. At this point, it's going to divide. So we're going to have some of the current going down this path through the ammeter and resistor 3, which has a resistance of 6R. This means that the current through resistor 3 is equal to 0.1 amperes. The rest of the current goes down this pathway to the other side, and we therefore see that resistor 2 and resistor 1 are in series. This means that the same current flows through both of them. Then the current meets at this point, flows through the light bulb, meaning that the light bulb experiences or has flowing through it the total current, and it returns to the other side of the battery. Now, very important over here is that the current flowing through this end of the circuit and that end are not going to be the same, since over here we have a total resistance of 6R and on this side we have a total resistance of 3R. Remember that in series we add together the resistances of the resistors to get the total resistance. Also remember that in series potential difference is divided. So that means, although the reading here is 3 volts, the reading of potential difference across the resistor 2 is not going to be 3 volts as well, because potential difference divides in series. However, grade 12s, if we connect a voltmeter across this part of the parallel connection and we go and connect a voltmeter over here across the 3 or resistor 3, we know that this reading and that reading is going to be the same because potential difference is constant in parallel. These are relationships that are incredibly important for you to understand because they're going to influence how you perform your calculations. Now, it's true that we do have a parallel connection, but please understand that a parallel connection does not mean that this reading and this one is equal to the reading on the voltmeter across the battery. In this case, we also have a light bulb connected in series with the battery. So whatever reading is displayed on this voltmeter connected to the battery or connected over the battery, it is going to divide between the light bulb and the parallel connection RP. So please make sure that you know all of these relationships very well to avoid any confusion or any calculations that are incorrect. So now that we know how the current flows and we have an idea of how this circuit operates, let's go on to the questions. Question 9.1 says, write down the value of the 9.1.1, the potential difference across resistor R2. Resistor R2 is over here. Its resistance is 2R. The resistor connected in series with it, called R1, has a resistance of R, which means the same as 1R. Therefore, resistor 2 has twice the resistance of resistor 1. Remember that in series, potential difference is divided. And the bigger the resistance, the larger the potential difference given to that resistor is going to be. Remember that the potential difference is going to divide according to ratios. So if the potential difference across resistor 1, whose resistance is R, is 3 volts, then it means that the potential difference across resistor 2, whose reading or whose resistance is 2R, is going to be 2 times 3 volts. It's going to have a potential difference reading that is 2 times bigger, giving us a reading of 6 volts. And therefore, the answer to question 9.1.1 is 6 volts. On to question 9.1.2, it says determine or write down the current through resistor 2. So the only current reading that we have here is the current in this part of the circuit. Remember, the current is going to divide. We have that the total resistance in this part of the circuit is 6R. The total resistance over here is going to equal to 3R because R plus 2R is 3R. Remember that in parallel, the current is going to flow through, or we're going to have a higher current reading where the resistance is lower. So if the resistance here is 6R and here it is 3R, and 0.1 amperes flows through the 6R resistance, then we know that twice the current is going to flow through the 3R resistance because current takes the path of least resistance. So the answer to question 9.1.2 is going to equal to 0.1 times 2 because 3 is half of 6. Okay, that means that double the current is going to flow through 3R, and therefore the answer to question 9.1.2 is 0.2 amperes. We now can move on to question number 9.2, which says calculate the resistance of resistor R1. Now, since we just determined the current flowing through the resistor 2, we know that since resistor 2 and resistor 1 are in series, this current flows through resistor 1 as well. We also know the potential difference across resistor 1. So to determine the resistance, we can say the resistance of resistor 1 is equal to the potential difference reading across it divided by the current that flows through it. This is going to equal to 3 divided by 0.2, where 0.2 is the answer to question 9.1.2. And this gives us a final answer of 15 ohms. So this means wherever R is, the value of R is 15 ohms. Question 9.2.2 now says determine the EMF of the cell, and we see that this is a question out of 6 marks. So to determine the EMF of the cell, we know that we will most probably need to make use of the formula E equals I multiplied by R plus small r. We know the internal resistance, we can determine the total resistance of the load, and we can also determine the current that flows through the circuit. So let's start off by determining the total current that flows through the circuit. If a current of 0.1 amperes flows through this part, and through the other part we have a current of 0.2 amperes, then we know that the total current is going to equal to 0.1 plus 0.2, which gives us an answer of 0.3 amperes. This is the total current flowing through the circuit. To determine the total resistance, we first need to add together these resistors in series. Resistance in series is equal to resistor 1 plus resistor 2. That is going to equal to R plus 2R. But remember, we now know the value of R is 15. So this is 15 plus 2 times 15, which is 30, giving us a total of 45 ohms. Then we need to determine the total resistance or the effective resistance for this parallel connection. That is going to be 1 over Rp is equal to 1 over resistor 3 plus 1 over the series calculation that we just determined. That's going to be 1 over 6 times 15 gives us an answer or a value of 90 plus 1 over 45. We plug this into our calculators and we get 1 over 30. We find the reciprocal and then Rp is equal to 30 ohms. Now, going back to this formula, We have the value of Rp. We still need the total resistance, so we must not forget about the light bulb, which has a resistance of 80 ohms. This light bulb is connected in series to the parallel connection. So in the end, we know that R, which is the total resistance or the load, is going to equal to, or the external resistance is going to equal to 30 plus 80, which gives us a total of 110 ohms. Now, going back to the formula at the top, we say EMF is equal to IR plus small r. This is going to equal to 0,3, which is the current, multiplied by the load, which is 110, plus the internal resistance, which was given to us as 1. When we plug this into our calculators, we find out that the EMF is 33,3 volts. And this is the final answer to this question. Now the marks will be awarded as follows. Firstly, you're going to get a mark for determining the effective resistance for the parallel connection. You're going to get a mark for the method you use to calculate the total resistance of the load. 1 mark for the formula for EMF, 1 mark for substitution, and 1 mark for your final answer. It seems like I've missed a mark. You're also going to get 1 mark for substituting over here. This gives us a total of 6 marks. We can now move on to question 9.2.3, which says we must determine the power dissipated in the light bulb. Now remember, there are many different formulae that we can use for power. But for this light bulb, we now know the current that flows through it and we know the resistance. So we can simply say that power is equal to I squared multiplied by R. The current is 0,3, which we're going to square. Don't forget the square. Multiplied by 80, and in the end we find that the final answer is 7,2 watts. Remember, power is measured in watts. You're going to get 1 mark for your formula, 1 mark for substitution, and then 1 mark for your final answer. Now the question says switch S is now opened. So going back to the circuit at the top, we see that the circuit is now open. If they open up the switch, then it means that this section on the right hand side is in a sense completely removed from the circuit. So that is no longer using up any energy from the battery. Current no longer flows through that circuit, that part of the circuit. So it is as though if we have removed resistors in parallel. So the question now says 9.3, write down the reading on voltmeter 2. Voltmeter 2 is this voltmeter over here. There is no longer any current flowing through this part of the circuit, and therefore this reading is going to drop to 0 volts. So the answer to question 9.3 is simply V2 is equal to 0 volts, and please remember to supply this answer with the correct SI unit. Question 9.4 now reads, a learner makes the following statement. When the switch is opened, the loss volts will increase. Explain in terms of total resistance and current why this statement is not true. So, we know that resistors were removed. These are resistors that were removed in parallel. When resistors are removed in parallel, we know that the total resistance, this is spelled very, very incorrectly. The total resistance is going to increase. So we say the total resistance increases. If you remove resistors in parallel, the total resistance increases. Now, if the total resistance increases, it means we have more opposition to the flow of charge. Therefore, the current is going to decrease. So the current decreases. Now, given that we have a formula, E equals IR plus IR small r, where we know that the EMF is constant and the internal resistance is constant. If the current decreases, then it means V internal with its constant internal resistance is going to decrease as well. Since the EMF is constant, it means that this value is going to increase to compensate for the internal decreasing. But in this case, we're not interested in the external, which is on the left-hand side. We're only interested in the internal. So we say, since the EMF and R is constant, this means that the internal, or we can call this the lost volts, will decrease. It will not increase, but it will decrease. So you're going to get 1 mark for writing down that the total resistance increases. 1 mark for writing down that the current decreases because of this. 1 mark for stating that because the EMF and resistance is constant, the internal or the lost volts is going to decrease. And this gives you your 3 marks. This question is out of 18 marks in total. And grade 12, this brings us to the end of this video.